Hello. So today we are doing this problem, making a large island. I have solved this problem earlier, and I don't remember a single thing about that. So I don't know if that's good or bad, but yeah, let's read the problem. You are given a n by n binary matrix, so n is equals to grid dot size. We have n. You are allowed to change at most one zero to be one. So okay, so we can change any of the zero, at most one zero to be one, within the size of the largest island in the grid after applying this operation. An island is four directionally corrected group of ones. Group of ones. Okay. So okay, group of ones. Okay, so something like flood fill comes to my mind. So let's delete this. If I have 1 0 1 0 and 0 1 1 1 1 0 1 0. Okay. So in this will be the largest island. Okay. And I think I can change 1 0. So if I change this zero, then this three islands will be connected. If I change this zero, then this two islands will be connected. If I change this, then this two island will be connected. If I change this, no, only one extra and this, then one. No. Okay. I have no idea. I don't remember anything how to do this, but I have some ideas that are coming to my mind. So let's look at those. What if I number like this will be of size 1 and I give it a number of something. This is of size 1, 2, 3, 4, 5, and I give it a number of something. And this is of size 1, I give it a number of something. So I go with this, I come to this, I do a DFS, and I find its size and give it the number according to the starting position. Yeah. So I come to this has not been visited. So I do this and give it a number according to the starting position. Okay, so I come this, I all of these are visited, this is not visited, and I give it a number according to its starting position. Or I just increment this number 1, 2, and 3. Okay. Now, when I come to this, I see I make this 1 and I do a DFS on both of these sides. Okay. I make this one and do a DFS on both of these sides, and I find the maximum size. Or I can just start by 0, do a DFS on both of these sides, or like all its neighbors. If I start from a 0 and do a DFS on all its neighbors, that could be a good solution. But what will be the time complexity? So what is 0? For this 0, I'll go all this nodes and this nodes. If all of them were 1, then I'll go all ones. But then there will be no 0. So I'll have to also find the largest ones. I think I can do that. I think I can come to a 0 and then find all, uh, do a DFS from 0 and find all of the largest one. Okay, so for this, the largest will be 1 to 1 plus 5. Okay, plus this, so 7. Now for this, the largest would be 5. For this 0, the largest would be 8. So 1, 2, 3, and these 5. For this, the but this also increases my time complexity by a lot. And if all of them are 1, if no 0 is found, then I return like the entire matrix. Let's try this. Let's try this. I is consider I smaller than n. I plus plus for in j is equals to 0. J smaller than n. J plus plus if grid of I comma j is equals to 0. 0 df dfs is equals to max of answer comma oh, is equals dfs of I comma j. Okay, do 0 is equals to 0. 0 is equals to 1. If not 0, return n into n as return answer. Okay, that works out. This will not work if I have zeros. Like if I have something like this, zero, zero. Okay. So answer will be four. Answer will be four. Answer will be five. Hmm. Okay, this will work. This will work. This should work. Let's see. Let's see. First thing. I zero or j smaller than zero or I is equals to n or j is equals to n. Vector int this and I'll pass on this here of size n comma vector n of n comma Manson. This of I j is equals to 1 n equals to 0 if it has already visited, then we return 0 if 1 plus EFS of I minus 1 comma j comma this I plus 1 j plus 1 j minus 1 Let's see if this works. Output is 4, but my answer is it works for this, it works for this, but not this. Okay, let's see why. Nope. Yep. Yes. Go into DFS. Nope. This will become 1. I minus 1 does not work. Return 0. I plus 1 returns that does so. Hmm. 0 comma 1 will return 0. Yeah, I plus 1 return 0. J plus 1 return 0. J minus. Okay. If grid of so I'll have to do this also. Okay. Uh, this is a problem. So I will have to backtrack a bit. So grid of I j is equals to 1. This if it works. Let's see the time complexity. The time complexity should be very bad. Oh, I understand this. Yep. Oh, can I see the time complexity? Where is it? All are zeros. So we could do all of them. All are zeros, so it will try to call DFS and all of them, but I think I can also optimize for just this if I want. If I do that, will it help? If I just optimize for all zeros. If I optimize for all zeros, what is the problem that I'm facing? Why is this a problem? Let's see. Minus 500. So 500 into 500. 250000. 250000. That's 2,50,000. Not a lot. 2,50,000 into 4. So that's 10 lakh operations. 10 lakh operations are 1 million operations. Okay, that's okay, I think. It should not be a lot. One lakh operations, 10 lakh operations, 1 million. 1 million is 10 to power 6. Yep, 10 to the power 6. 10 to the power 6 is okay. I don't know why this is a lot for this. If I can check here only, then I think I can do better, I guess. I will not need this. I will not need this. And oh, oh, is equals to 0. If grid, I mean, do a slight reduction. Let's see. By checking all the four sides. is equals to plus 1, uh, plus 1, comma 0, comma minus 1, comma 0, comma plus 0, comma minus 1, comma 0, comma plus 1. Cool. And 3 equals to 0. K smaller than 4. K plus plus. And x is equals to x is equals to del of k I plus del of k comma 0 and y is equals to I j plus del of k comma 1 so if x greater than equals to 0 and then y greater than equals to 0 and then x smaller than n and then y smaller than n and then grid of amount y is equals to 1. Answer look plus is equals to the fs of x comma y comma s. This will be a local answer. This will have one also. Probably we'll have still have that time complexity problem because 1 million operations is not passing. This does not change anything. Some way I have to store. So this is a basic operation that I can see. Now somewhere I will have to store this value if I am at this point at a 1, I think I can number them. Let's say I number this and this is number 1. Okay, let's come back to it. This was 1, 0. Let's but okay. So what I can do is I come here, I do a DFS and I store this value as 1. I come here, I store all this as 2, and I do a DFS and I store 2 as 5. I store 3 is 1. So that's how I can easily do that, I think. So unordered map and for in I equals to million and I plus plus. Okay. And for int j is equals to 0, j is smaller than n, j plus plus. Okay. Now, now if grid of I j is equals to 1, then int number is equals to 0. Number is equals to, let's say, let's start from 2. Start from 2. So I make all of them as 2, and I also calculate the size. That is the plan. So let's do a DFS too. I don't think I'll need this DFS, so let's do it here. If grade is equals to 1, MP of n- number is equals to DFS of I j. Okay. Now how will this DFS work? I don't need this visitor. Now grid of ij, comma, number not equals to 1. Of ij is number plus plus. Okay. I do a DFS, change all of them to number, and I also get the answer. And okay, and here I just check the adjacent ones. Let's just see. Then, okay, there's no whiz here, so number. Yes, I know it's a wrong answer. I have to do a logic here, but I want to see if this thing works. It changes the grid. My grid does not seem to change. Why is my grid the same? This third grid of ij is equals to 1. MP, let's see, MP of 2 is 1, MP of 3 is 1. That is cool, but this hasn't changed. Why is this so? 0 comma 0 is 1. It goes inside and 0. Yep, that changes. Okay, so my this dot grid has changed. I think that is what's happening. I should do this. Yeah, my this dot grid has changed. Now answer answer 1 plus, let's make that end there 4 comma 2 is equals to 0 comma minus 1, 0 comma 1, 1 comma 0, minus 1 comma 0. Okay. Now for int I think we have got this answer. I is equals to 0. Sorry, k is equals to 0. K is smaller than 4. K plus plus. Int log is equals to 1. And if int x is equals to I plus k there of k comma 0, int y is equals to j plus there of k comma 1. Now if x greater than equals to 0 and then y greater than equals to 0 and then x smaller than n and then y smaller than n, answer log plus is equals to mp of this dot grade of x y. Okay, something's wrong. Generally, this is not done. Okay. Alright. Not now. Ah, I see what is happening. I have to fix this. So for this, it will also get the same answer from top and from this also, from the left also. So that is a problem that needs to be solved, and I think that will do it. Let's see. From the top, from the top, 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 from the top. If I have already seen, if I make a scene, and then scene, mm, and it works. I hope there's no time complexity issues. That is scaring me. Okay, still TLE, still TLE. Still TLE. Why TLE? This will go M into N, and this will go M into N. Ah, I don't need this visitor. Oh, oh, creating that visitor again and again was causing. I understand. Time complexity was what good. It's not good, obviously, but was okay. But it was causing errors due to that visitor. Barely, barely, just barely. And less complexity. I mean, to n square, yeah, n square, because there is no m. Okay, let's look at the editorial. Okay, okay, okay. Okay, very similar to mine. Very similar, very similar. Okay, there is also a DSU version. I would like to see the DSU version. Okay, very similar, let's say. Hmm. The union, all the current and the neighbors. If current is one and the neighbor is one, we union it. And if we find a zero and the neighbor is one, we insert. Okay, and then we can calculate. Makes sense. Very good. It took me like 1 hour, I guess. Yep. Can do better. I would like to do better, but it is okay. I guess